Hello and welcome to the Cisco Support Community's Expert Series webcast. A few housekeeping notes before we begin. As you enter the WebEx console, you either joined us via audio broadcast or by phone, which was automatically muted. Because of our large audience in attendance today, you will remain muted throughout the event. When you have a question, please feel free to enter it into the WebEx Q&A panel located in the bottom right corner of the console. Please leave the chat window available to communicate with the WebEx facilitator for any problems or issues you may experience today. We would appreciate your feedback on today's event by taking the short survey that appears when you close your browser at the end of the event. My name is Francine Richards, and I'm the Web Marketing Project Manager for the Cisco Support Community and moderator of today's event. The Cisco Support Community is an online forum with over 500,000 members where you can get answers to your technical questions prior to opening cases with the TAC. You can answer many questions or contribute and rate documents, videos, and blogs. The community can help you boost your career by becoming a top contributor and getting the technical community to know about your expertise. We invite you to use the community on a daily basis at supportforums.cisco.com. Today's topic is Demystifying Unified Computing System UCS Interfaces for Troubleshooting with expert Niles Pyelshak. Before we begin, we would like to let you know about some upcoming events that may be of interest. On April 7th, our Expert Series webcast will be on SourceFire integration on the ISR G2 and ISR 4K routers with Corelli Sanker. Corelli will be covering SourceFire IDS mode integration on ISR G2 and ISR 4K routers, along with the live demo. You can register for this and other upcoming webcasts by clicking the link in the chat window. Be sure to look for other webcasts coming soon via the Cisco Support Community by visiting the Experts Corner knowledge sharing page. We have a few Ask the Expert discussions coming up. Running now through March 27th, Cisco WebEx Meeting Server, install configuration and troubleshooting and finesse for UCCX Next Generation Agent Desktop, and transitioning from CAD. Find these and more by visiting the Expert Corner knowledge sharing page. And if you haven't already, then be sure to join the Cisco Support Community where you can share current real-world technical support knowledge with your peers and experts. Check out the Class of 2015 Event Top Contributors and Spotlight Awardees on the Cisco Support Community. And if you're interested in conducting an event for us and becoming a top event contributor yourself, please go to the Experts Bureau and sign up. Take a moment to rate the content of your peers' documents, videos, and blogs. In doing so, you'll help us recognize the wonderful content that they contribute. Ratings encourage more contributions. And now, on today's presentation. Our expert joining us today is Niles Pyelshak. Niles is a customer support engineer for Cisco TAC and works in the server virtualization team. She has several years of networking virtualization experience. She recently passed her CCIE certification in Data Center 44608. As a network engineer, Niles was accustomed to getting on the command line interface to configure and build her network. In server virtualization, it is a little different, and she is always amazed at how servers are mostly managed by graphical user interfaces and CLI. One cannot underestimate the power of both interfaces, and in this webcast, Niles will leverage both GUI and CLI to demonstrate the UCS life of a packet. Assisting Niles today is Robert Burns. Robert is a technical leader in the ACI Solution Support Team with 16 years professional experience, specializing in data center products and technologies. As a technical leader, Robert is responsible for assisting with customer support issues, mentoring new team members, improving the Cisco support experience, and contributing to Cisco certification tracks. Highlighted career certifications held by Robert include Data Center CCIE, Microsoft MCSE, and VMware VCP. Robert has presented at Cisco Live in the U.S., Mexico, Australia, and Canada, making this his 6th year presenting. If you would like a copy of the presentation slides, you can click the PDF file link in the chat box. And there will be an Ask the Expert event following this webcast as well through March 25th, and Niles will be continuing the discussion in the Ask the Expert event. So if you have more questions, please visit the Knowledge Center on the Cisco Support Community. And also, after the presentation, you can come back and visit the topics under the Knowledge Sharing Corner. On each event the support community presents, you will find links to FAQs, videos, presentations, downloads, and discussion. Ask the Experts are quickly accessible. So for today's Expert Series webcast, Niles will start with her presentation and demo for the next 60 minutes of the program, and then we'll dive into the live question submissions for the remainder of the event. During our live presentation, you may submit questions for Niles to answer using the Q&A box on the right side of the console. So please begin posting your questions now to give her the best chance of answering them. And we'll be asking polling questions during this webcast, and we highly encourage you to participate by answering them. When the webcast ends and you close your event, please take the survey and let Niles, Robert, and us know how you rate this event. Now we'll get started with today's event. We're going to start off with a polling question. Do you have Unified Computing System, UCS, in your data center? A, I have UCS B series but not C series. B, I have UCS C series but not B series. Or C, I don't have UCS and have never used it. So please take a moment to answer that, as this will give Niles an opportunity to tailor her presentation to meet your needs. And now I would like to hand the mic over to Niles, who will start today's presentation.
Great failures or performance troubleshooting. So when I thought about that, I said, well, usually these are isolated incidents. Why do I want to present on isolated incidents? What common denominator do customers face that I can actually present and allow the customers to learn more about UCS? And what I thought about is, why not take some time and discuss the interfaces that UCS have? There are plenty of them, as you guys may be aware of, and today we're going to take it apart and understand what is what and how they relate to passing a packet from the servers all the way to the network. Okay, so here is the list of things on the agenda. We're going to basically talk about the UCS domain. We're going to discuss the components of the domain and what that looks like. We're going to talk about the forwarding, the modes of operation, which is in-host mode and switch mode. We're going to discuss unified port. We're going to talk about chassis connectivity and server connectivity. And then we're going to paint a picture of what traffic flow looks like in the UCS domain. And then we're going to go into talking about UCS interfaces. What are they, and where do they connect to? And we're going to take some time and discuss spinning, fabric failover. If we have some time, we're going to talk about some basic troubleshooting on UCS domain. And then we're going to basically follow a packet. So basically trace a packet all the way from a server until it exits the fabric interconnect. So first of all, from a high level, what does a UCS component look like, domain look like? First of all, you have Fabric Interconnect, okay? These are your connection to the outside world, okay? You have storage devices in a data center. You have networking devices. Basically, those upstream switches are going to connect to the Fabric Interconnect. This Fabric Interconnect has 10 gig uplinks, and they could be native fiber channel ports or unified ports, such as CoE or lossless Ethernet, okay? They can connect up to about 20 chassis or 160 servers. And then you have fabric extenders. Fabric extenders are basically this muxes that fits into the chassis. Each chassis are going to have two of them, IO Module 1 and IO Module 2, okay? And we also have external to the chassis effects that you can actually connect your C-Series server to the effects and connect it back to the Fabric Interconnect. Next, we have your compute devices. These are blades that actually insert right into the chassis, and they could be different form factors. They could be a half-width blade, or they could be a full-width blade, okay? There's quite many flavors of them. We're not going to talk about the different flavors because we want to focus on understanding merely UCS interfaces. And on the right-hand side, you can see here there's a rack mount server. Obviously, that's a compute device as well, but it is not in the chassis itself. And then you have your UCS VIC. Okay, this is the virtual interface adapter. These are called converged network adapters, and they are basically your interface to the I/O module. Essentially, when you have a server, you have a NIC card. Your CNA are the things that connect to the back of the chassis and allows traffic to traverse the I/O modules and leave the chassis going towards the Fabric interconnect. I don't know, as you see all of that picture, you say, wow, there's so many different components to it. Do I have to touch all of them to manage them? No, you don't exactly have to touch all of them with different interfaces. We have what's called UCS Manager. Okay, at the top of this diagram is the UCS Manager. This is basically where you manage everything in this domain, from your port configuration to your I/O module to your service profiles and your CNA adapters. Okay, everything basically happens at the UCS Manager. Okay, the UCS Manager runs in active standby mode. Essentially, you have a UCS Manager chip on the Fabric interconnect, and whichever Fabric interconnect is primary, that's the one that you're going to instantiate your UCS Manager from, okay? So in a nutshell, that's basically the components of UCS domain. All right, here's the portfolio. There's a quite variety of UCS components, and I am just going to focus on the Generation 2 modules. Okay, you've got the 6248 as well as the 6296. Basically, the difference is in the rack unit, port density, and how much bandwidth you want to pass through them. Fabric extenders, we have the 2204s and the 2208. This gives you a certain amount of uplinks leaving the chassis as well as back traces to the servers. Okay, and then you have different types of virtual interface cards: the 1240. The 1280, as well as the 1225 that is used for the rack mount servers. Okay, so I mentioned unified ports. All the ports on the FI 6248 are unified. And what does that mean essentially? That means that every port on the Fabric interconnect can basically, on a mere configuration of a sliding scale, you can change the port roles to either become a fiber channel or a lossless Ethernet port. Okay, so what you see here in this picture is exactly the same picture of what a Fabric interconnect looks like. Okay, 6248 in this picture has 32 unified ports. And on the right-hand side, that is an expansion module that you can insert and take out on the fly, okay? If you need to configure them, if you need to configure this unified port, you basically need to click on this link, configure unified port. If you click on it, it will take you to the next page. So basically, this is what you get. Okay? So basically, you click on this link, there's a slider here that allows you to decide which port you want to run as you want to configure with the fiber channel role or lossless Ethernet. You basically just slide your way through here and determine, and just set it at where you want your ports to be lossless Ethernet versus fiber channel, okay? The best practice is that you actually use the expansion model for your fiber channel. That way you do not have to reboot the device when you change this. So the gotcha is that if you do need to go in and change a port role from fiber channel to Ethernet after deployment, you have to come in and change this slider. When you change this slider, you will be required to reboot. Okay, so if you use the expansion model for the fiber channel, that allows you to only reboot the expansion module. Okay, obviously, if you're changing the port roles on the base card, then obviously you're going to have to reboot the base card, and most of the time that's going to take a hit on your production. All right, what are the forwarding modes of operation on a UCS domain? First of all, you have end-host mode. Okay, right out the box, you have end-host mode. Okay, basically, what this means is that all of your UCS will behave as a server to the northbound devices. It behaves as one server. Okay, therefore, if you have a server, you have ports that you're connecting to your network. All those ports are going to be forwarding, okay? In this case, if you have your FI in end-host mode, that means that you're going to have all your uplinks non-blocking, okay? Spanning tree does not come into play here, okay? And basically all your servers are going to be dynamically pinned to your uplinks. So that's why we do not need to utilize spanning tree protocol, okay? And switch mode. In switch mode, this is user configurable, which means you actually go in there and you decide to change your Fabric Interconnect from in-host mode to switch mode. When you're in switch mode, be aware that that means that you're going to learn MAC addresses all the way from the northbound devices as well as from the southbound from your UCS domain. In in-host mode, you will only be learning MAC addresses from your servers, okay? So your uplinks do not perform any MAC address learning. So those are the two modes of operation in a UCS domain. All right, let's put everything together. This is a logical picture of a UCS domain. As you can see here, we have two chassis, chassis 1 and chassis 2. Okay, and in the middle of this chassis 1, you see B200. That's one of our half-width blades. Okay, and as you can see, there's a CNA on it. That converged network adapter is your NIC that is placed on the back of the adapter, and when you slide it into the chassis, there's a trace that's created between that CNA to the I/O module. Each of the chassis usually has two I/O modules in them, and all the CNAs are going to have traces to the I/O module. For instance, this particular CNA has a trace going to I/O module A, and also has a trace going from the CNA to I/O module B. Okay. And from there, the I/O modules have a server uplinks that connect to the Fabric Interconnect. Okay, so I/O module A will connect to Fabric Interconnect A. I/O module B will connect to Fabric Interconnect B. These rules are very, very simple, and they must be strictly followed. Okay. In between the Fabric Interconnect, you're going to see a cluster link. Okay, if you look on the Fabric Interconnect, you're going to see L1 and L2. Okay, L1 on Fabric Interconnect A must be connected to L1 in Fabric Interconnect B, as well as L2. Okay, so in order for remember, I don't know if you recall earlier on, I told you that the UCS manager run in active standby mode. This is the link that is used to synchronize data in between these Fabric Interconnect. Okay, so it's very, very important to make sure that you've got L1 connected to L2, and L1 connected to L1, and L2 connected to L2. Okay, and then northbound of here, you're going to see the green uplinks are going to your storage devices, maybe it's a SAN, whatever you have northbound of there, and then you've got the red links. These links are going to your network devices, and obviously we've got out-of-band management. All right, so what topologies do we essentially have when we are deploying UCS? You have several topologies, and that is dependent on the type of I/O modules that you have and how many uplinks you want to actually connect to the Fabric Interconnect. So these are your FIs. They are deployed usually in pairs for high availability. You do not have to have two of them. Essentially, you can deploy one Fabric Interconnect in standalone mode. But in my experience, most customers, they need the high availability in the data centers, and they usually deploy these in pairs. All right, let's say you want to have 20 gig uplinks to your Fabric Interconnect. Okay, essentially you will have one link from I/O module A connecting to FIA, and then you also have one link from I/O module 2 connecting to FIB. Okay, that would essentially give you 20 gig per chassis. Okay. If you want to have more bandwidth between the chassis and I/O modules, you can do two uplinks between I/O module A and FIA, two uplinks between I/O module B to FIB, and so on and so forth. Again, this depends on the type of I/O modules that you have, that you can insert inside the chassis. If you notice here, there's a trend. Okay, you've got 2 by 1 link that gives you 20 gigs, or 2 by 2, 2 by 4, 2 by 8. And if you look, we are missing some numbers. We're missing 3. 3 is definitely not a supported number because these links actually use the powers of 2. Okay, what are I/O modules? I/O modules are essentially fabric extenders. They are not switching. They're not intelligent at all. All they do is packets comes into the I/O module, and then they get sent out. Okay, they do not do any spanning trees. They're exactly Ethernet, strictly Ethernet, lossless Ethernet, and basically you have links from the I/O modules going to the Fabric Interconnect. Those are called NIFs, network interface. And then you have links going from the I/O module tracing back to the back of your server. Those are called HIFs. Okay, those are called HIFs, and they are exposed to your servers. All right, so here is a diagram of what the I/O module, one of the original I/O modules that we have, I/O module 2104, okay? Essentially, you've got, looking at the ASICs, I can't think of the ASIC's name right now. I believe it's Redwood or so, but I can't think of it. So I put it's got an ASIC with a funny name. At any rate, what matters is that you have 4 uplinks to the Fabric Interconnect, okay? These are your NIFs. Okay, and then it exposes its backplane ports to the blades. These are your HIFs. Okay, that's very important to understand as we go forward. Essentially, this is what it looks like. This is a logical picture. Please keep in mind the I/O module 1 typically is placed on the left side of the chassis. Okay, what I want to drive home with the slide is simply that each of the servers are going to have traces to each of the I/O module, which in turn connects to the 2 separate Fabric Interconnect. Say, for instance, Blade 1. Blade 1 has a CNA, and it has path A that connects to I/O module A. It also has path A that connects to I/O module B. Okay, if you would like to have more paths switched on between the CNA and the I/O module, you need to take serious consideration into the type of adapter that you purchase. Okay, we're not going to talk about the combination. There are several of them. We might highlight a few of them, but there are several combinations that you would need to take in consideration during design. Essentially, all these lines here are your HIFs, and these are your NIFs that go to the Fabric Interconnect. All right, here's the architectural picture of the 2200s. These are the generation 2 I/O modules, and as you can see, if you have a 2204, you're going to have 4 NIFs going towards the Fabric Interconnect. If you have a 2208, you have 8 NIFs that go towards the Fabric Interconnect. The 2204 also has 16 NIFs that are exposed to all of your servers, okay? And the 2208 gives you 32 HIFs that are going to be exposed to your servers. Again, I want to highlight this again, that there's no local switching that takes place inside the I/O modules. All right, so what does this look like in UCS? If you actually log into UCS Manager, you can see a lot of things. But you can also SSH into UCS Manager virtual IP address and look around and do some configuration there as well. So let's say you SSH into a Fabric Interconnect and you do show interface brief immediately. You're not going to get anything. It's just going to scream back at you. What are you doing? I don't understand that command. It's not going to give you a good response if you do show interface brief. Okay, because there are different level of XML application, a tree that you have to go through within UCS to perform certain functions. Okay, if you want to view the interfaces, you must connect to NXOS, shell. Okay, so if you want to see the HIFs between the I/O modules and the servers, you just connect NXOS and you do show interface brief. There you will see all of these interfaces. ETH111, essentially what that means is that this is chassis 1. The middle number is always 1. I think that refers to, one Fabric Interconnect, but that number is always 1. And then the last digit refers to the blade. Okay, don't worry, we're going to talk more and more about this until it's driven home, okay? But essentially, this is how you're going to view your I/O modules from a HIF's perspective. All right, server connectivity. Okay, so remember we talked about you can have several modules of CNA, and we're going to take, for instance, we're going to look at M81KR adapter that's connected to a 2104 adapter. I mean, an I/O module. Okay, as you can see, here is the adapter that's on the back of the blade. There are several traces of that the I/O module exposes to the server. But because you have an M81KR, you're only able to utilize one of the traces, okay? So essentially, you're going to have one 10 gig trace connection HIF that goes to the I/O module A, and also one 10 gig connection that goes to I/O module 2. And all these other interfaces will not be switched on. Let's say, for instance, you have a 1280 VIC, and that is connected to an I/O module 2208. All right, that is going to enable you to have 4 traces enabled per each of the I/O module. Okay, now let's talk about traffic flow. Essentially, let's say you've got a host, an ESX host, and on that host you have VNix. Okay, for example, here you have virtual machine 1 that has a VMNIC 0, and then you have virtual machine 2 that has VMNIC 1. Okay, and as you can see, both of those VNICs are connected to FIA. Okay, so let's say what happens if virtual machine 1 needs to communicate with virtual machine 2. What will happen? Essentially, that packet will come, that frame will come all the way from the virtual machine, goes to the Fabric Interconnect. And because this Fabric Interconnect has learned all the MAC addresses for the service it connects to, it's going to say, I know where this guy is going to, and then it will go ahead and forward that frame down to the VNIC 1. By itself without sending that packet or the frame northbound at all. Okay? That's very, very important to understand. So essentially, that VM will communicate between each other using that FI that they're both pinned to. All right, say for instance you have 2 virtual machines that are pinned to different Fabric Interconnect. What does that traffic look like? Essentially, what that means is that when VM1 tries to communicate with VM2, it comes here that the FI will say, well, I don't know where this VM is actually located at. I am going to send it northbound, and then the layer 2 switch will go ahead and forward it down to FIB, and that's how the virtual machine 2 is going to get those packets. So essentially, that's the traffic flow for that scenario. All right, UCS interfaces. This is UCS interfaces. So when I first started in the server virtualization team, I thought, wow, there's just too many interfaces. What do they mean? And where are the documents of what they are and how are they used? And sometimes it's not always very easy to find things on CCO. So I thought, okay, let's paint pictures of what these actually are and at least the most used ones that we're going to interface with. Let's talk about it. So logically, this is exactly what you need to know. This is exactly what you need to know, all the way from the virtual interface that's created on the CNA all the way to the northbound devices. Okay? All right. Let's talk about this. As you can see, you have 2 Fabric Interconnects. The Fabric Interconnect, the uplinks that are connecting to your northbound devices, those are called uplink ports. Okay, those are the ports. Those are essentially your division between the UCS domain and your outside network. Okay, those are always called the border ports or uplink ports. Okay. At the bottom there, you have your server ports. Those are also called Fabric ports. Okay. In the middle, those are your network interfaces. Okay. these are exposed, these are the cables that you're actually plugged in from the I/O modules to the Fabric Interconnect. As you can see, these are the I/O modules. This is a logical picture, so normally the I/O modules are not sitting outside of the chassis. They are actually inserted in the chassis, but I just wanted to paint a good picture of what this looks like. But essentially, this will be where your HIFs connect to the adapter itself. So these are HIFs that speak through the I/O module, that converses through the NIFs, and once it gets to the Fabric Interconnect, it gets switched through the uplink port. All right. Here's a polling question. What are the two types of VIFs that are available to you? All right, so let's talk about VN tag. So when I first joined the SV team in tag, I thought, VN tags, these things are just so complicated to understand. Essentially, they are not hard to understand, okay? They're they're super simple to get if you just understand that they're just a tag that are set in place to identify the interfaces on your blade. So if you recall, I said for M81KR adapter, you have two 10-gig links or traces that are exposed to the I/O modules, okay? Now, when you load a hypervisor or operating system on the server doesn't see that. What does the server see? The server is going to see a VNIC, VHBA, and things of that nature. And you may have 2, 3, 4, 5, 6 of them. I don't know. But essentially, we need to have a way to identify when packets come down to the server, which interface am I going to pass that packet to? And essentially, the VN tag gives you the ability to identify each of the VNICs in and of its own. You, as an engineer, do not have to, or as administrator, you do not have to configure this on your own. The system automatically does this for you. But it's helpful to really understand what's going on under the hood. Okay, so this is just a logical picture of it, of what I just explained. Essentially, each service profile, which is the identity of the server, may have several HBS and several VNICs. Okay, well, we need a way to identify which link or which physical source and logical source the packets are going to be sent to and delivered to the actual virtual machines. Okay, so it's just a VN link. All right, so how can we view this? This is actually a command that I use quite a bit, okay? It gives you a great bit of information. You can SSH into your UCSM. Once you SSH into your UCS and you do connect adapter 111. Question to you guys, which server is that? That's too easy. Obviously, that's in chassis 1 and server 1. So I should have come up with something much more complicated than that. But essentially, you can connect to that adapter and view more properties regarding that adapter. Once you connect to the adapter, you can attach MCP and then issue this command VNIC. Once you issue the command VNIC there, it will tell you how many VNICs you have. In this case, there are 3. The names of them, VNIC 1, 2, and 3. It will tell you the VNIC type. In this case, these are Ethernet. It will tell you the state of those VNICs, which are up. Okay? And here are the lifts and the lift state. The lifts are essentially your VN tag. Okay? So VNIC 1's VN tag is 2. VNIC 2, VN tag is 3. And so on and so forth. And as you can see, they're all up. Now, the UIF is essentially the DCE interface. If you actually log into UCSM and you expand your servers, you can drill down to the adapters and actually see the DCE interfaces. That's what UIF is referring to. Okay, the 0 is referring to the primary FI. That is, it's pinned to the primary FI, and 1 is indicating that VNIC is pinned to the secondary FI. Okay, and obviously the arrow is telling you that that's the current pin situation. Okay, that VNIC right now is actively using the path, the DCE path, and the HIVs through the secondary side, okay? All right, here are the VIFs. What are VIFs? VIFs are essentially your interfaces on your virtual network adapters. Okay, there are two types. You've got the Ethernet that are used for SCOE traffic and Ethernet, and then you've got your virtual SCs that are for SC traffic only. Okay. If you would like to take a look at them, you would just go into NXOS and you can issue show VIFs, interface, port channel, whatever number that you choose. And you can do show port channel summary, and that will give you a list of all your port channels, and you can take a look at it that way. In this case, we can see that this particular port channel has 3 vEthernet interfaces. In fact, there are 4. Pardon me. There are 4. Okay. You can see there's 2046, 47, and 48. And then, whoa, there's another one here at the end that has higher 1,000 number vEthernet number ID. Okay, that essentially means that that is going to be mapped or bound to a virtual fiber channel interface. So this is going to be, if you drill down further, it's going to show you that it is bound to a VSC. All right, so let's take a look at that further. Show this internet interface port channel 1280. That tells you all the vEthernets that are available on that port channel. And as you can see, there's another high number vEth here, 8978. And if you do show this interface vEth 8978, that will tell you that it's actually bound to VSC 786. Okay, obviously there's a variety level of virtualization that's going here, and we need to identify it somehow. Another way to find out the VIFs is basically to go into the FI, SSH into the FI, and you can issue the command show service profile circuit, the name of the service profile, or you can do the server, and that gives you quite a bit of information. In this case, we can see that that server name is bound to is attached to associated with server 11. Okay, and it lists its virtual interfaces, its VNIC names, the link state, are they active or not, and the border pin port, the border uplink port. And you can also drill down, show run interface vEthernet 697, and that will tell you all the particulars for that vEthernet. And it can also tell you that it is actually bound to a HIF interface of server 111. All right, let's look into UCS Manager. UCS Manager, once you log into the UCS Manager, you can click on the Server tab and highlight your specific service profile. And as you can see, it correlates. So you can click on the VIF tab on the right-hand side on the working pane, and you can see that Show VIF Ethernet ETH112 tells you all the vEthernet that are being used there. And right now we are on Fabric Interconnect A, so you're going to get information regarding the path leading to A. If you wanted to see information about the second path, you would need to maybe connect to NXOS B so that you can see the particulars as far as VIFs and vEthernet VFCs are concerned for Fabric Interconnect B. All right, histonist pinning. Okay, it's very, very important for me to highlight that when a server is turned up and you've created VNICs and you've created all your failovers and those sort of things, you've created your service profile and you're ready to go, all of the servers are going to be dynamically pinned to your uplinks, okay? They're going to be dynamically pinned. Now, you can do some static pinning if you want to do some engineering, that's fine, but you have some limitation depending on how many links you have between your I/O modules and your Fabric Interconnect. Okay, so for instance, we have a chassis here that has 8 servers populated in it. These numbers right beside it, 1 through 4 for slot 1, these are the heads interfaces that are being exposed to the blade from the I/O module perspective. Okay, essentially you have one link here, one NIF that you have physically connected one link from the I/O module to the Fabric Interconnect. So therefore, all of your servers they are only going to pin to that one link because that's the only uplink that you have given to it. Okay, they're going to be dynamically pinned to that one link. Okay. Let's say that you have two links. It gets a bit more interesting here because you can now pick up a few servers and pin them to a specific uplinks. Okay. Again, if you're doing dynamic pinning, it's going to automatically pick server or slot 1, 3, 5, and 7 and pin them to the first link, and then the even number blades 2, 4, 6, 8 are going to be pinned to the second link. These are predetermined. You do not have to go into your UCS manager and configure this. Okay, these are dynamic pinning. Here's an example for you. I had one case some time back where the customer was calling to say that they're doing some performance testing, and whenever they pull the cable, that they don't lose any packet. So then I asked them, can you explain to me and show me exactly what you are doing? So obviously you've got the administrator sitting in the office somewhere. They've got site support, your hands and feet in the data center that's, doing everything for you. So the guy logs into the UCS manager and he says, okay, we're going to do performance testing for slot 2. He tells the site support, go ahead and pull the cable out of the IO module. And he's already begun sending pings, to the northbound device. So he's sending a ping from slot 2, and the site support removes this first link. And nothing happens. Like all the packets continue passing, and he continues to get replies from the ping. And I thought, man, yeah, this Cisco engineers, we are really good. When in fact there's a problem. They're not seeing any problem there because the guy pulled the wrong cable. All right, so this is why I'm taking time to show you guys the spinning, because it's very important when you're trying to troubleshoot or test different scenarios to actually understand how the pinning has been already done for you and has been predetermined for you. All right, so let's say we have four links between the IO modules and the Fabric Interconnect. Obviously, that means that now you only have 2 blades that are using 1 10-gig uplinks. As you can see, the slot selection is 1 and 5 are going to pin to the first one, and so on and so forth. Now, you might say, you know what, I want all my servers. I have 8 servers in this chassis. I want them to get 10-gig dedicated Ethernet uplinks to the Fabric Interconnect. Well, you know what, you can purchase an IO module that allows you to do that. Essentially, you've got slot 1 that is pinned to each of the links going to the Fabric Interconnect. Keep in mind, guys, as I'm talking through this presentation, feel free to ask all your questions if I'm missing something, so it could be answered at the end. All right, let's talk about IOM failover. So for instance, let's say that you have an IO module and it has 4 cables plugged into it. Okay, so now you have all your servers that are pinned to 4 links between the IO module and the Fabric Interconnect. All right, and then one of the links fails. Okay, what that means is that you have 3 links that are going to continue to pass traffic. Okay, so those 3 links will continue to pass traffic. All right, and let's say you want to say, man, I want to make sure that all my blades are repinned accordingly to the IO modules and the Fabric Interconnect. Well, that means that you need to go back into the UCSM and re-acknowledge that chassis. When you re-acknowledge the chassis, that means that you're now going to reduce your number of available links in that IO modules to 2. Okay, because obviously 3 is not supported. All right. What I suggest to my customers is just important. It just makes sense to go ahead and just replace the link instead of having to, do a react of the chassis. In some scenarios, a react of the chassis would essentially cause a downtime, obviously because you're doing some rehashing on the virtualization interfaces. All right. When you're doing dynamic pinning to all your separated uplinks, that's called discrete mode. Okay. You have your servers that are individually pinned to the IO modules, and they get pinned to your Fabric Interconnect. You can also create port channels. Okay, there's a way you can configure it. You can configure it using the UCS Manager or CLI if you so desire. Okay. You can actually also do a port channel between the actual servers and the I/O modules. Okay. There's a specific scenario that allows you to do that, and that is simply if you have a 2208 as well as a 1280 adapter. That usually gives you a lot more bandwidth. It just depends on what sort of application that you're driving or what you're preparing for the future. All right, port channel pinning. Okay, so if you go into the UCSM and you connect to NXOS and you do show port channel summary, you're going to see a plethora of port channels depending on your design and your implementation. For instance, here we've got some port channels here, port channel 1, 220s. These are your border port channels. These are your uplink port channels, okay? And then you've got port channel 1025, okay? This port channel 1025, as you can see, is got member port, Ethernet 117, 18, 19, and 20. Okay, these are the port channel between the I/O module and the FI. Okay, so these essentially are your NIFs. If you look in here and you see any port channel from 1200 and higher, this essentially means that you have port channels, you've chosen to create port channels between your blade and the I/O modules. Okay, so for instance, this blade 12, this port channel 1280. You can see it has his 1/1/29. This means that you essentially created a port channel to the CNA for server 8 in the chassis. And these are your heads interfaces here. All right, fabric channel of port channeling in the UCSM. Basically, the way you go ahead and create this is by launching the UCS Manager. You click on Equipment, you highlight Equipment here, and then you go over to Global Policies. Well, here you can set your discovery policy. You can say, well, you know what? Every chassis that I add to these domains, I want to require that it has 2 uplinks before it can be discovered. Okay? And then you can also select the radio button to say, by the way, I want you to create a port channel for me. All right, fabric failover. How does that work? Here's a polling question for you guys. What is the preferred failover method? Is it fabric failover or is it software failover using your operating system, whether you've got bare metal servers or hypervisors or whatever? What is preferred? What are the best practices? Fabric failover. Okay, so here we are in in-host mode, okay? And you essentially have your adapter here that has 1 VNIC. That VNIC has, you've gone in there and you've created, you've highlighted, you've selected that you want fabric fail, you want the UCSM to handle failover for you. You click the radio button. What that's going to do is create a standby link going to your secondary fabric interconnect. And then it also has 1 link that will be active that it's pinned to your primary fabric interconnect. It's very, very important to highlight here that the second link that's going to the fabric interconnect is merely on standby, but it's there. You can actually log into NXOS and actually see it, but it's going to tell you, hey, I'm not working, I'm currently in backup, so that if something happens to this link here, this guy would be deployed immediately and your traffic will continue being passed. All right, so let's take a look at what I just explained. Fabric failover. You go into your UCS Manager, and as you're configuring your VNIC, you enable failover with a mere click of a button there. What is that going to give your server? If you do show service profile circuit, it's going to tell you, okay, here is your server. This is how many VNICs you have. Again, these links are all up and active. But wait a minute. If you look at the protect role here, you can see that that is actually active. and is active, and then the role of this Fabric Interconnect is primary. So right now, your traffic from server 16, VNIC 1 are using FIB to pass its Ethernet traffic. If you look up here, the other VNIC is there also, except for the state is passive. And the role is currently backup. Let's say something happens and you lose your primary link, then VNIC 1237 is going to kick in and become active. It's going to tell you, yeah, I am backup, but right now I'm the one passing traffic. All right, so let's say something happens and you go in and you correct the problem, it does preempt. So, you know, the VNIC one that was originally active and as you configured, it would go ahead and preempt and go back to primary, and the backup link will go back to passive. Following a path of a packet. Now we're going to dig much deeper. All right, you guys are aware that a service profile it's merely an identity of your server, okay? So let's say you want to find out, you want to basically trace a packet. I want to see from my VNIC level all the way to the border links, and how does it traverse and go to my storage devices or my networking devices. You go into the Fabric Interconnect and you issue the command, show service profile, circuit server, the name of the service profile, or the actual server. Okay, so you choose the server. Again, this will display all of this information. 1236 is actually your virtual circuit that is attached to VNIC 1. It is up, it's active, and it's currently primary. And as you can see, it is pinned to the border uplink 19. If you want to actually view the border interfaces, you can do show pinning border interfaces, and it will tell you, yes, I have Ethernet 19 as my border interfaces, and yeah, by the way, I have these series of virtual interfaces that are pinned to that uplink, okay? And as you can see, Ethernet 1236 pinned to Ethernet 19. Okay, so let's say you run the command show pinning interface. We're going to go forward. All right, so show pinning server interfaces. What is it going to tell you? It's going to tell you, okay, my Ethernet for that VNIC 1 is 1236. All right, so show pinning server interfaces is going to tell you the actual Ethernet that has been created for that server. It's going to tell you the border uplink that is pinned to, and the reason I like this command is simply because it can tell you the duration in which it has been pinned to that uplink. Okay, usually sometimes customer will call in and say, yeah, my server, you know, rebooted or link fell or whatever. This allows me to say, okay, no, it did not. Yes, it did. Okay, so it's very helpful. It can get a little confusing, but it's very helpful. Okay, so let's paint a picture of that. We know that our virtual circuit for that VNIC 1 is 1236. All right, and we also know that it is traversing. It's pinned to uplink port 19. All right, so then we're going to basically follow the packet and learn all the other interfaces as we go forward. So right now we know server 11 VIF 1236 is pinned out of Ethernet 19. Going forward, show interface Ethernet 1236. That will tell you the HIFs. HIFs, again, are ports that are exposed to your server. And if you want to look much more, if you want to dig a little bit deeper, you can do show interface Ethernet 1236 details, and that will give you the HIFs associated with that VNIC and that virtual interfaces. And look what's here again. It's a VN tag number. And remember, you do not have any control over that namespace at all. You don't have to configure it. UCSM does a very clean job in taking care of that for you. All right. You can also run show this interface Ethernet 121, and that would, yeah, we're still not talking about the same guy, the Ethernet 1236. What does that look like? Okay, let's put it together. We have our virtual circuit 1236. we know that that virtual circuit is pinned out of the border port Ethernet 1.9. Now, from this previous syntax, we now know that the virtual interface is using ETH1.121 as its HIVs. HIVs being the traces between the I/O modules and the CNA, your data. All right, show text details. I want to know what are my server uplinks. I want to know between the I/O module, which links am I pinned to. You can do show text details, and this will give you a variety of information. As you can see, it says ETH12 is one of them. You can scroll down, and you can see your HIV interface, Ethernet 1.121, and you can see that it's up, and that is pinned to Ethernet 1.2. Okay, so 1.2 essentially are those uplinks that you've inserted in the I/O module, and you have connected to the Fabric interconnect, to the Fabric port or the server port. Okay? All right, so now what do we know? We know again that we have virtual circuit 1236 that is pinned out of my FI port 1.9. My HIVs, my backplane traces is Ethernet 1/1/21, and we know that it's using CNTAG 2. Going forward, and then we also have the concept of the designated receiver that says, you know, I'm going to receive my broadcast through the port. In a nutshell, this is what I've talked about here again and again and again. Okay. This picture here is what I have printed and I've posted in my office. Ask me a question about what's going on here and there, you know, I turn around and we take a look at this. Essentially, what's going on here is everything is put together. You've got your server that has a VNIC. As you can see, this VNIC, it has a Fabric Failover enable on it. Okay, so you have your backup link that's been created through your DCE interface and pinned to FIB. You have a primary V Ethernet that are connected to DCE1. Tells you that the HIV port that is connected to is ETH1.1. You want to know information about that link? You go into the FI, connect NXOS, and you issue show text detail. Okay? Again, these are the HIVs that are exposed to the blades from your I/O module. Okay? And then let's take a little bit further. All right, so here are NIVs, and you want to find out information about what NIVs your host is connected to. You can see that by issuing the command show text details, show interface text fabric. I/O module is connected to. From the Fabric interconnect perspective, it is called a server port or a Fabric port. Okay? And as you can see, if you would like to find out information about the virtual circuit all the way from the VNIC to the Fabric interconnect, you will issue show service profile circuit, server 1.1, or show run interface, v Ethernet 740, and so on and so forth. Okay? Now, if you want to find information about uplinks leaving out of your network, you can issue the command show pinning border interfaces, show port channel summary. You could do show this CDP neighbor, and that will tell you who you are connected with northbound. What that allows us to do is basically make the C-Series server behave as if it is an actual blade. So we know that it's not, but you can actually integrate depending on the firmware that you have in your UCS domain. All right. Initially, there are different ways you can deploy this. You can deploy it using 2 wires, or you can do single wire. Okay. Recently, in our latest UCSM code 2.2, it allows you to directly connect the rack mount service to the Fabric interconnect. Okay. I don't know if you guys are familiar with the C-Series server. There's actually a bug that the memory that the SIMC would have memory leak every now and then. Once you integrate them inside the UCSM, you're still susceptible to that bug, whereby you need a power cycle to go ahead and clear that memory leak. What I've been telling my customers to do is if you're running a firmware on the C-Series server that is susceptible to that bug, with UCS Manager, you can actually log in and reset the SIMC on that, and that will clear that leak before you do your, OS patches, whatever you need to do that requires reboot, so that you don't lose control of the guy. All right, so we have one more polling question here. Are B-Series servers required to integrate a rack mount service into UCSM? Yes or no? Okay, so we're going to basically do a recap of the presentation that we've talked about. The first thing I said was that the UCS domain behaves as a server in end-host mode. It's very, very important to understand that and drive it home. It behaves as a server that allows you to have non-blocking ports, okay? In switching mode, again, remember that means that switch will behave as a typical layer 2 device that learns MAC addresses and allows you to configure trunking and configure, do traffic engineering as it relates to VLANs that you're going to pass. And then again, because spanning tree is involved, it would switch off redundant links, okay? You still have that available to you if you do need to run it in that mode. Obviously, here we have, what else did we talk about? We talk about the bandwidth. Okay, so as you're selecting what type of VIC you want and what type of I/O module you want, keep in mind the bandwidth and the throughput that you want, and that's going to basically give you the way to design your UCS domain, okay? What else I want to highlight? Yeah, I want to highlight this. Okay, UCS interfaces in a nutshell. There are VIFs that are created automatically when you have VNIX, and we have VNTAGs that identify all your VNIX that are exposed to the operating system. Then you have HIVs. HIVs are your host interfaces that are exposed to the servers from the I/O module's perspective. And then you have NIVs that are exposed to the Fabric Interconnect from your I/O module. Two types of virtual interfaces, VEAT for SCOE traffic, as well as your SCOE traffic, as well as your lossless Ethernet. And then you've got VFCs. The VFCs are for your fiber channel traffic. And then, of course, you have your border interfaces. So in a nutshell, that's basically it. Okay, there's a plethora of other interfaces that UCS has, but if you're trying to track a packet and you understand this, basically you're good to go. All right. So basically, if you I don't know if anybody in here is studying for the CCIE or not. If you understand these paths, basically, I would say you're basically very much equipped when you have to go and build connect your UCS C-Series to your NXOS or your Nexus devices, and you have to configure all those things by hand. But here in UCS, the UCS does it for you automatically. There are a few things that I always leave with my customers. One is the UCS emulator. Obviously, when you have a UCS domain that is in production, you can't really tamper with it. Well, most of the time, you don't need to tamper with it until something is broken or you need to redeploy, perform an upgrade, things of that nature. So oftentimes, my customers, they don't have access to playing around with these sort of things, creating service profile, making different scenarios. So I always give customers the UCS emulator to go ahead and load it onto a VM and play with it. It's very nifty. Obviously, you don't have hardware attached to it, but it allows you to have, hands-on experience with UCS Manager. Another thing I also give my customers are the fault codes. Okay, every fault that you get in UCSM, you're gonna have fault code associated with it. Okay, essentially that will give you an idea of what the root cause of the problem is, and you can try to sort it out yourself. And if you can't, obviously Cisco TAC is always there to rescue. That basically concludes my presentation.